Thanks, Rose of Sharon, for some very useful and practical advice. Remember, she'll be available at the end of the next presentation for a roundtable discussion and Q&A session. So our next presentation is another detailed and informative case study on the digital transformation at Tier 1 automotive supplier, Detroit Manufacturing Systems. Our presenters are Mo Abuali, CEO and Managing Partner of IoTCO, and Isaac Bennett, Digital Transformation and IT Manager at Detroit Manufacturing Systems. Mo Abuali is a strategic and transformative technology and business development leader with a 20-year record of driving and sustaining change in manufacturing. He serves industrial and manufacturing clients in numerous industries, including automotive, aerospace, and defense, by providing digital transformation, industrial IoT, and predictive analytics technology and services. Isaac Bennett has worked in the IT field for almost 20 years and has led numerous digital transformation initiatives to help manufacturing plants around the world implement smart manufacturing projects. So please welcome Mo and Isaac.
So yeah, thank you very much for the introduction. It's good to be here, giving this presentation with the PMA. So my name is Mo, and I'm a managing partner with IoT company. And I'm also glad to be here with my good friend Isaac Bennett from Detroit Manufacturing Systems. Our topic today is to present to you an automotive digital transformation journey, okay? And before we go deeper into the presentation, just to set the stage, as a company, the Internet of Things company, IoT Co., our DNA is the automotive industry. So we have been working in automotive and discrete manufacturing for many years. We specialize in two domains of experience. Most of our activities focus within the factory operation, so a smart connected factory. However, some of our activities also focus on products, so smart connected products. We are a team of senior manufacturing consultants, analytics, data scientists, and Internet of Things and automation experts, headquartered in Cincinnati, Ohio. Most of our work is actually in the Midwest, including Detroit. I personally have been in the industry for about 20 years. I've worked with companies like Toyota, TMMK, and conducted projects with a lot of automotive tier suppliers, many large, but also many smaller manufacturers. Like the Detroit Manufacturing Systems, actually, Isaac will introduce the company later. It's a mid-sized manufacturing company. So our agenda for today is really four things. I'm gonna preface the presentation by giving some introduction and definitions around what is the Internet of Things, okay? What is industrial Internet of Things, industrial IoT? And what is the role of technologies like predictive analytics and OEE and manufacturing execution systems, okay? So we want to talk about digital tools that can support any manufacturer to mature their digital journey in a phased approach, keeping return on investment in mind. And then I'll hand it to Isaac, and he will discuss his journey, personal journey, and the journey of his organization, Detroit Manufacturing Systems, along digital transformation. So let's get started. You know, the field of Internet of Things is by no means a new field. It has been around for many years, many decades. You know, we've been monitoring safety critical assets and machines and components for many years, even though it was not called IoT, but there has always been the use of data collection, the use of the internet, and the use of connectivity to collect data from jet engines, trucks, airplanes, homes, cars, power plants, nuclear operations, et cetera, et cetera. So the Internet of Things is a field about using the internet connectivity and analytics to cover all industries, all things, and all devices. When we look at the field and domain of experience where we play, we talk about the industrial Internet of Things, or IIoT. And when we look at a factory operation, we usually are looking at the ISA 95 layer, which is a standard of the IT architecture of an operation, a manufacturing operation. And that starts with the machine layer. So your CNCs, your PLCs, your sensors on the factory floor, okay? That goes into SCADA, which is your supervisory control and data acquisition layer. So that's your data lake, that's your historian, that's using things like MT Connect to capture data from CNCs, using OPC to capture data from machine controls, okay? So that's your data acquisition layer. The data lake typically flows into a manufacturing execution system, an MES. So this supports you to do your dynamic scheduling, your traceability, your OEE, your analytics. It ties your shop floor with your top floor, which is your enterprise resource planning system, your SAP, your Infor, your Oracle, right? What we find in a lot of factories today is some of these levels exist, some of them do not. For example, many companies may not have adopted an MES system, okay? Some of these levels are older software or legacy software products, and some of these layers may not exist, okay? It's fragmented. So when we talk about an Industry 4.0 strategy, fourth industrial revolution strategy, we're talking about connecting these layers in a cohesive way and merging and converging information technology with operational technology, IT and OT. And later Isaac is going to talk about their story of how they were able to make that convergence happen between IT and OT. So Industry 4.0 is a strategy, it's an initiative for manufacturers today to start adopting industrial IoT practices and improve productivity. So in a nutshell, when we talk about a Industry 4.0 or a digital transformation strategy, we're talking about 4 pillars that manufacturers today should keep in mind as they evolve their maturity on the digital horizon, right? We usually start from the right and go backwards. We start from the ROI, the return on investment. So what is the business case? And I will show some examples of improvements in uptime, improvements in OEE, reduction of scrap and quality issues, improvement of spare parts, right? So technology adoption and digital maturity must be able to impact your business bottom line, which is your P&L, right? Your profit and loss statement. And then we go backwards to connectivity. Are you connected? Are you collecting the right data that is meaningful for the business case you're trying to achieve? Next, we talk about analytics. Now that I have the data, what do I do with the data? How do I have real-time metrics? And how can I predict future behavior or future issues down the road? And once the strategy is proven on a smaller scale, maybe a pilot scale, we talk about scaling that technology. We talk about architecture, rolling it out to more machines, more factories, more geographies or continents across the world, right? So what's the technology architecture of scaling that solution? So your business case, getting connected, doing analytics, and deploying the right architecture for the technology. These are the 4 key items that I'd like to touch upon. And then Isaac will educate us on how practically they were able to do this within their operation. I want to give a very simple definition of Industry 4.0. This is a nice graphic, you know, showing the transition from Industry 1, 2, 3, 4. I mean, Industry 4.0 is about digital connected world, right? It was initially a German-led initiative by the German government, which was scaled in Europe and then later was scaled in the United States. In the US, the National Association of Manufacturing, NAM, they refer to it as Manufacturing 4.0 or Smart Factory, right? Different organizations have different namings. You know, GE refers to it as Brilliant Factory Initiative, for example. But I want to give a very simple definition, and the definition is Industry 4.0 is about combining traditional manufacturing practices today with the technological world, okay? Industry 4.0 at its heart is about technology and process, but also about people. And the right mix of people, process, and technology, and the right way that this transitions, okay, from an Industry 3.0 to a 4.0 domain is our approach and how we see manufacturers being successful. So let's briefly talk about people, process, and technology. And I want to start with people. This may be the most difficult, actually, bubble in the Venn diagram because there's a lot of change management required, maybe improvement on the culture side, and how to make the data and the technology integrated, cohesively with the people. We like to say the right information should be sent to the right person at the right time. And we see a lot of manufacturing environments today that are starting to become more automated. So moving from operator controlled to an operator intervened to even a lights out manufacturing operation, right? So I heard an interesting naming. They called it a dark factory. A dark factory is a lights out operation that may not require operators to be actually controlling the machines. So it's important to understand the maturity around the people side and the general strategy of evolving the people side of the element in the operation. Then we talk about process. We're seeing a transition from reactive thinking, short-term thinking, manual, processes, to more proactive, scheduled, long-term approach to running your process, to even self-optimizing processes where data is connected automatically, decisions are made automatically, decisions may even be fed to the machine automatically or the line, so the line can have a self-optimizing approach to running the actual operation, right? So there's an evolution on the process side. And then there's the evolution on the technology side. Manual, traditional machines and assets to more digital CNC and PLC controlled solutions and systems, to the use of artificial intelligence and machine learning to cover the whole value stream, to understand what is the health of your machine, what is the health of the spindle bearing and the ball screw on your machine, and make proactive decisions, right? But we believe that it's important to understand the digital maturity across your people, technology, and process. And usually the best transition or transformation to Industry 4.0 is governed by your weakest link, okay? So if people is your weakest link, it is important for the company to try to focus there and make an evolution versus trying to deploy technology in a factory where maybe the people side of the coin is not ready, right? So with the right recipe around people, process, and technology, there is a quicker approach to achieve ROI and profitability in your digital transformation journey. So speaking of ROI, it's important to start with the business case, okay? And it's important to track metrics. OEE, overall equipment effectiveness, is a key metric today in manufacturing, okay? And by collecting data and having visibility and delivering the right information to the right person at the right time, absolutely the OEE metric is a key metric to be tracked in real time and to be improved. And predominantly uptime is a key metric within OEE, availability, performance, quality, right? So the uptime is a key metric for some operations. We are also looking at using analytics to improve maintenance activities. So by catching, detecting, and reducing unplanned downtime by using analytics, there is a great opportunity to optimize maintenance activities and to move from a proactive maintenance environment to a predictive and preventive maintenance environment. We see manufacturers tie into their spare part inventory by having a data collection and a predictive approach to monitor your assets. There is no need any longer to keep a high value of spare parts waiting for things to fail. So we see manufacturers using analytics to drive reduction in their spare part inventory and being able to be predictive in the replenishment of new spare parts. We see manufacturers optimizing their maintenance schedule and moving from a time-based and reactive maintenance approach to a more usage-based and predictive, proactive maintenance approach. And the numbers I'm showing here, are true numbers from manufacturers today, large and small, who have embraced analytics, who have embraced connectivity and data collection. And they have seen immediate improvements anywhere between 5 to 20% in their overall equipment effectiveness, 5 to 10% in their utilization, reduction in spare parts of almost 25% by being able to optimize maintenance and use analytics, and reduction in labor time. You know, when we used to work in automotive plants, you know, when you go and fix a machine, you have a very strict time-based schedule, and you would go in on a robotic, for example, and you would change the bearing in all the 6 joints of the robotic. But now that we're able to sense data from the robotic and predict that a specific joint is going to fail before it fails, you can reduce the labor time, you can fix the right area in the robotic, and you can reduce your spare parts. So it is a maturity curve. It's a phase approach for your digital journey, but it all starts by getting connected, analyzing the data, and having proactive decisions. Some manufacturers have eliminated overhead maintenance. You know, due to the time-based schedule of maintenance, they used to run maintenance on weekends, you know, Saturdays and Sundays, but using analytics and making optimizations, they've actually been able to eliminate weekend maintenance and drive a very, you know, just-in-time maintenance approach to their factory. So start with the business case and have the business case dictate where you are today, and then what technologies should be enabled to support you to digitally mature in your journey. I want to touch on a few technologies just to give you a feeling. I want to touch on connectivity to the machine layer. I want to touch on data collection and metrics. I want to briefly touch on manufacturing execution and predictive analytics. I want to give a hint to some of the digital tools that are around today. And I'm going to start from kind of the industry 3.0 up to the industry 4.0 technologies. And the reason I'm doing this is, you know, we believe that those 4 pillars you see up here are indicators of your digital maturity, okay? And we actually have an assessment approach when we work with clients that we go in and we do a digital assessment. And during the assessment, we are looking at and evaluating and benchmarking where the manufacturer is regarding connectivity, acquisition, metrics, and MES, and then using that to create that digital readiness analysis and report to support the manufacturer to move to the next level of the maturity curve. So ask yourself, and you may already know the answer, you know, what is your digital maturity today across those layers, your machine, your data collection, your execution, and even your ERP, okay? Let's start at the bottom of the pyramid. Connectivity. You know, some say manufacturing data is the new oil, okay? Manufacturing data is the foundation to achieve ROI. It's very important to have a data lake, and that data lake should be able to support multiple systems that you have, be it your OEE system, be it your ERP, or be it your execution system, okay? When we go in, we look at and ask a few key questions. We look at, is the machine capable of communicating today, okay? It's important to understand that, you know, in any manufacturing facility, there is new machines, there is older machines. Some machines have an Ethernet port. Some machines have been around for decades. They're still running. They're still making good parts, but they are legacy machines, and there has to be a way to communicate with those machines. It's important to look at the network side and the cost benefit of networking and cabling the machines and making them IoT ready or IoT enabled. We look at time, right? How long is it actually going to take? And what is needed on the machine to be active, and what is needed externally on the software side to be active to communicate to the machine, right? And then the most important question is, at the end, is actually, what data do you need from the machine? So what is the use case? And the use case dictates the type of data that I need to capture from the machine. And I'll talk about some examples here. But we always start with an audit, okay? A senior automation controls person would visit the operation. Depending on the size of the factory, there will be a 2-day, a 3-day, or a 4-day audit. It's important to open control cabinets, look at schematics, and have a clear understanding of of the age and the capability of the machine to communicate to the outside world. And then we have a connectivity process that we follow, okay? We look at the network readiness, okay? Does the machine have an Ethernet port? If so, is the machine connected on the network? If yes, what is the data map that I need to capture from the machine? What are the signals or tags that are indicative to the OEE or to the use case that I'm trying to derive from the machine? If I'm looking to capture real-time OEE on a machine, for example, I'm looking at the cycle start on the machine. I'm looking at machine on off. I'm looking at a piece counter. I'm looking at maybe a reject signal from the machine. I'm looking at the fault code, right? What is the fault codes or the warnings that are happening on the machine? So there are specific data maps or data models that are important to identify, and those data models are then made available using a data lake, a historian, an OPC server, a MT Connect agent, right? There's many ways. Of course, it is dependent on the machine type, the capability of the machine, the age of the machine, and so on and so forth. But it's very important to make your assessment here on the connectivity side, because connectivity is your foundation, and connectivity enables the rest of the systems to go in place in the right approach as you mature your operation. So now that we're connected, the data starts flowing, and the data is used to drive real-time metrics to the manufacturing operation. And we define two types of metrics. We define performance metrics, which is historically giving you an indication of this is your overall equipment effectiveness. That's your OEE per machine, per line, per building, per plant, right? And enterprise level benchmarks. And don't get me wrong, there's many other performance metrics as well. There is your mean time between failure, your mean time to repair. Some folks use TEEP, theoretical efficiency of the machines, right? And then we talk about predictive analytics. We talk about health of the machines, predictions of issues that might happen, remaining useful life. When is my spindle bearing on the machine going to fail before it actually fails? So if we look at it from a simple iceberg chart, okay, a lot of folks are measuring productivity today. They're measuring pieces, how many scraps, you know, how many hours the machine was running. But if you look under the surface of the water, we're talking about unleashing the opportunity in the hidden factory. We're talking about metrics that drive productivity. We're talking about uptime, real-time uptime coming from the machine controller. We're talking about performance, measuring the speed of how long it took you to actually run a part. Your ERP is a great solution. It's telling you that your standard time to run the part is 30 minutes. But you know, how much do you trust your standards today, and how can you improve your standards, right? By communicating to the machine and tying the shop floor to the top floor, you're able to clearly understand machine runtime, part runtime, which is your performance, and quality. Okay, how many pieces, how much scrap, what was the reason for scrap or the reason for rework, and in some cases, additional quality information and measurements. And then you have below that, the health of your asset. Is my spindle bearing on the machine going to fail? The remaining useful life of your asset, how long, how many days or weeks is it going to take for this to fail? And diagnosis, what is the root cause? Is it the inner race of my bearing? Is it the outer race of my bearing, right? So, you know, even though some manufacturers are measuring OEE today and they have a good level of maturity, they're running 90% OEE, 85% OEE best in class, but yet the machines fail. And when the machines fail, there is unplanned downtime and there are issues with spare parts and issues with maintenance, right? So we see those folks that are measuring OEE and having a high level of digital maturity, you know, ready to embark on that journey using AI and predictive analytics. So metrics, what metrics are driving your business case based on the connectivity? And then you have visibility, right? Visualizing your overall equipment effectiveness, integrating data from the factory floor together with data from your enterprise resource planning system. We're talking about solutions, many solutions available in the market today that give you a web-based, mobile-based experience so that every role on the factory floor is clearly aware of planned versus actual. We like to say, what is the score on your shop floor today? What is the real-time score? And here, your score is shown versus your target. You're actually behind. Your score is behind. This is the target quantity from your ERP system that you're supposed to make today during this shift, hour by hour. And here, based on machine data, is the actual number of pieces that have been produced in your operation. So when I look at this, I have a real-time understanding of where I am versus where I should be within my manufacturing plant, and I can take action and I can make decisions proactively. Right? Then we talk about expanding. We talk about the MESA organization, which runs the manufacturing execution systems. It's a global organization. They, categorize execution on the factory floor in 4 buckets. They talk about production, inventory, quality, and maintenance. OEE is the start. That's your production operations. But how about traceability and genealogy of my part, especially in aerospace and automotive? If I have a recall or a warranty issue, how do I trace that part back? How do I have a birth certificate of my part from the raw material to every operation that it went through on every machine, every person, directly to the end product that was shipped and maybe placed inside my car that is running on the streets, right? So traceability is key. And at the end of the day, these manufacturing execution functionalities like traceability and quality and warehousing and maintenance are modules, okay, to your manufacturing execution that can be enhanced and added over time as that digital maturity improves and as the level of connectivity improves over time. We also believe and see in the industry today the use of templates, okay? I mean, gone are the days where you have a toolbox and you have to develop and you have to create things from scratch. There are many out-of-the-box solutions today for large organizations and small organizations that are very affordable, can be deployed rapidly in weeks and deliver value in days and weeks and not months and years. Now, the last piece is predictive analytics. So now we've gone through connectivity, metrics, OEE, manufacturing execution. So the tip of the iceberg, the holy grail maybe for some more mature manufacturers is, now I have the data. Now I have the data lake. I want to start doing predictive maintenance. I want to predict issues on my machine before they happen. I want to start doing prescriptive analytics and predicting quality issues on my part before I make a bad part, okay? So now we're talking about tapping into that same data lake and using, again, pre-built solution templates and artificial intelligence and machine learning and advanced mathematics, right? To deliver more value to the manufacturing organization, okay? When we look at manufacturers today, we look at a variety of processes: high volume manufacturers, low volume, high mix operations, low mix operations. We see capital intensive industries with a lot of robotics, CNC machines, casting, stamping, ancillary equipment, right? And in our domain of experience, and as we come from manufacturing, we have an industrial data science team who really excels at using vibration sensing and using data that's coming out of the control to be able to give more insights to what's truly happening in the machine, okay? Is my axis on the robot going to fail, and when is it going to fail? Is my spindle bearing or my ball screw on the machine degrading, because that degradation might lead to an issue on the machine? My casting equipment is very complex. I have 50 to 100 process parameters being captured in casting and molding, right? And there is a direct correlation between the casting parameters and the health of my injection rod in my injection molding machine and the health of the part that is being produced. If one of those parameters is out of spec, it might lead me to make a bad aluminum cast or a bad plastic mold, right? So by using analytics and correlating process parameters, machine parameters with quality data, we offer more insights into predicting machine issues and quality issues on the part. So I think the situation again boils down to how out of the box these solutions can be, how affordable these solutions can be, how quick to deploy it can be, and how easy and intuitive those solutions can be for manufacturers today. If we look at just an example here for a CNC machine, right? We're talking about a complex machine. We're talking about multiple components that might degrade, including bearings, your ball screw, your feed axis. But the end user here is the maintenance organization, okay? Once the data is captured from the machine, the maintenance organization is looking for an intuitive way to understand, is the machine performing? Is it degrading? What is the reason for degradation, right? And when is the machine gonna fail before it fails with an accuracy, okay? So on the left here, you see the data model. You see data that's coming through the controller using Empty Connect. You see data that is captured by vibration sensors, for example. So high frequency data, low frequency data from the machine control. But for the maintenance user, the regular maintenance person, we do not expect them to be a PhD or a data scientist, right? They need an intuitive way to look at the data and understand easily that this machine is healthy, okay? Your health is close to your baseline here. This machine has started to degrade. It entered a warning zone over time. And then this is your remaining useful life. You have the following amount of time to act, and you can receive predictive alerts by email, by text. You can create a predictive order, a work order in your maintenance system. So you can order a spare part in time before the machine actually fails. You can see here that we're looking at the bearing within the spindle, and we are capturing the failure harmonics. 8 kilohertz is the failure frequency of the bearing, or the outer race of the bearing, or the inner race of the bearing, right? So predictive analytics is about using advanced mathematics and techniques, but representing that data in an intuitive way, using an HMI, a human machine interface that is easily understandable by the shop floor team, so they can act and make decisions to improve productivity. So those are technologies we see across the way when we talk about getting connected, visualizing the data and the metrics in real time and tracking them, getting to a full manufacturing execution with trace and quality and SPC, and then using that data to drive your predictive analytics journey, maybe for the more mature organizations. And to do all this, there has to be a team behind it. There has to be a business case established. And I think I'd love now to hand it to my good friend Isaac Bennett from Detroit Manufacturing Systems to talk about his journey and his level of maturity, and give you some insights on how they went through that journey to success. So with this, Isaac, floor is yours.
Thanks, Mo. Let me turn my fan off here. We're kind of living in a new normal, so forgive me. I have a window open behind me. You might hear some birds. And I got 3 kids and a dog, so hopefully we get through this presentation unscathed. Yeah, my name is Isaac Bennett. I'm the head of IT right now at Detroit Manufacturing Systems, which Detroit Manufacturing Systems is a cool little story, and I'll tell you a little bit about that. So yeah, about 18 years IT experience. I've been in the automotive industry for 9 years, almost a decade. Yeah, so you can go to the next slide, Mo. So Detroit Manufacturing Systems founded in 2012. They're a pretty young company. It was founded with the idea of bringing manufacturing back to the city of Detroit. So it's a joint venture with Faurecia, which is a bigger tier 1. We have plants in Detroit and in Toledo, and we're a world-class tier 1 component manufacturer. Core business, you can see the pictures on the left and the right. In Detroit, we are doing a lot of value-added assembly, just in time, just in sequence stuff with Ford. You see the cockpit there and center console, same with the Jeep products in our Toledo facility. And we have in Detroit about 30 injection molding machines where we're doing some molding for some of those parts that we put in the vehicles. You can go to the next slide. Yeah, so I'll tell you about my journey. I've only been with DMS for a little over a year, so a lot of the things I'll reference are from my previous experience at a different company. But I think the story rings true. So a lot of these slides, I'll probably be telling a story and trying to describe my journey to you so that it can be relatable and you can kind of grasp onto some of the concepts and ideas. And I would say a lot of the stuff that I'm going to talk about goes along with a lot of stuff that Mo just previously talked to you about. So I can tell you that the story from my perspective is I had the opportunity to go and be an IT manager in our company's facilities in Europe and South Africa. And I was managing the IT people who were working directly on the manufacturing floors. And I would meet with leadership as much as I could to get messages from them because I really wanted IT to be a business partner. And the messages that I got consistently were, we need more help on the plant floor from IT. So when I came back from there and I started to I was sitting in an IT strategy meeting, global strategy meeting with the company, I brought that fact up that the plants were really wanting more technology and more help on the plant floor. And I was tasked with going out and finding what that solution was. And this was about 5 years ago where I said, okay, what can we do? And I sat down and I started researching what we could do, what technology was out there. And I came up with the help of my CIO with a presentation that at that time, when I first sat down to do this presentation 5 years ago, I didn't even know what Industry 4.0 was or smart manufacturing. But that's what the presentation turned into, was a presentation about smart manufacturing and the things that we're talking about today. But the thing that we quickly realized as we made this presentation, we delivered the presentation, we had a lot of positive feedback. Thing we quickly realized is that a lot of people in the plants are very busy people. They're trying to get products out the door with the best quality possible, and they got their heads down and they're working hard every day. Sometimes they don't look up to see what's going on in the technology world and what they could be doing. You know, they just need to get their job done and get the job done the best they can. And we noticed that a lot of departments were like that, in silos. A lot of plants were like that. They were living in their own worlds in these silos and not talking and communicating with each other. So we really quickly realized that it really starts, and Mo mentioned this, it starts kind of with the culture of innovation and trying to get people to think outside the box and not just think inside their box, but bring those teams together that are, you know, from a broad range of departments. You know, the supply chain people weren't talking to the quality people, and quality people didn't talk to the maintenance people, and so on and so forth. So that's what we quickly realized. Some plants had MES systems, some didn't. There's no standard solution for MES, no standard solution for data. Data was not gathered or not used. Sometimes data is just gathered because you're compliant to, from compliance standards, you got to gather data. So that was the beginning of the digital transformation journey for us, of kind of figuring out, okay, here's the concepts of Industry 4.0. We quickly realized that we need to talk to each other more. We need to collaborate more. We need to figure out how to process this. You can go to the next slide, Mo. So the one thing that was realized was, okay, what is Industry 4.0? And here's the framework of Industry 4.0 on the left. It's a very busy slide, talking about, you know, all the different things that are involved. Industry 4.0, a lot of the things that are involved with Industry 4.0 are nothing new. It's just they put it together with a name and a framework. And you know, Mo mentioned it's a concept from Germany originally. It's like anything else. Like there you see on the left, cloud computing. I mean, cloud computing's been around for a while too, before they named it cloud computing. So I would encourage people not to be scared by the concept of Industry 4.0. It's a lot of different things. And you see the ring on the outside, data analytics, big data, mobile devices, advanced HMIs. smart sensors, a lot of different things, even additive manufacturing or 3D printing is considered Industry 4.0. But really what it comes down to is the middle there, the core of that, and it's data and analytics is the core capability. So it's across the value chain and across the products and services that you have, and even across business models. And so that's what we came down and really realized. And if you look at that quote on the left, that the goal is to generate knowledge from data in order to transform the company into a learning, agile organization and enable rapid decision-making and adaptation processes through every part of the business and across all business process areas. That's really, for me, what it came down to. And Mo, you can go to the next slide. Yeah, so it really, if you talk about it through the value chain, Industry 4.0 is really a compelling case for innovation and also a compelling case for collaboration. It's not going to work if we don't collaborate together. We have to figure out how we can sit in a room together and solve problems, automation problems. You'd be surprised sitting in groups together that haven't sat together, what they learn from each other in those rooms. And the capabilities that we have today with Industry 4.0 and what you can do with Industry 4.0 in helping with that collaboration is really amazing. And I have to point out that really, this not really being a new thing, but the concepts being put together as a newer concept, it's really been enabled by how inexpensive it is. Not only internet connection or network connectivity is less expensive than it was, 10 years ago, but you can get a smart sensor that's, can fit in the palm of your hand, that can do 10 different things. And those sensors are relatively cheap. You can get one that's obviously not an industrial strength, but you can get one that does 10, 12 different things and can broadcast to the cloud for under $100. So technology by nature gets cheaper, and that's where we're at right now. We're able to get a hold of sensors, use the internet, use the cloud, use those technologies that are getting less and less expensive, and we can use them on a manufacturing floor to help with that collaboration and to gain knowledge from those devices. You can go to the next slide. So the next step that we took as an organization was, and Mo alluded to this a bit, was, okay, we know what Industry 4.0 is. We know we need to be more collaborative. So the next step for us was saying, okay, where are we as an organization with our maturity level? Where would we be considered? And I would imagine most people, and even today, most people are probably at number one. This, if you look at the right there at the top, that's reactive automation, standalone manufacturing. So that's, I think, where I am right now at Detroit Manufacturing Systems, is we're very reactive, but the culture, we're really building that culture right at Detroit Manufacturing Systems. We have a smart manufacturing committee now. We're talking about specific issues that we can work on, and we're trying to get out of that reactive automation with Detroit Manufacturing. But then where do you go from there? Well, then you go to site excellence, where you have preventative maintenance, quality improvements, energy management, which hasn't been mentioned yet, but that's a big part of Industry 4.0. And there's amazing things you can do by tracking the energy of your machines. And you can actually use that for preventative maintenance as well. Asset performance. But then if you're just one plant, step 3 isn't exactly for you, but you would go to, okay, then where, if I have a site excellence, where do I reach from there? And then you go down to connecting your global value chain. So not just collaborating inside your plant, but how can you collaborate outside your plant? And there's some great tools right now that are coming out that are web-based tools where you can connect them into your providers. You can, have labeling that's already coming to you from your providers and from your customers. invoicing connected. There's all kinds of cool things that you can be doing from that standpoint. So thinking outside just your plant, but to the global value chain. And you can probably hear my dog barking outside. Well, you can go to the next slide. The one big thing for me being an IT guy, is we learned really quickly that there's definitely in a lot of manufacturing facilities, the IT guys work on the enterprise, the ERP system, they work on the back office systems, but a lot of the IT guys are not touching the OT domain, which is the operation technology domain. And if you don't have an MES right now, MES is a great way something to put in, a great tool for measuring your performance on the plant floor, gathering OEE, visualizing data, but it also is a great tool to use to get your IT department and your operation technology guys together in a room, figure out how you're going to implement something like that, and then figure out how you're going to get the data off the plant floor into other tools in the back office, into your ERP system. But there's definitely been a divide between the IT people and the operations people. That gap is shrinking fast. And there's so much technology that's going in the plant floor these days that you got to have your IT people hooked up with that. So we're talking about collaboration again, making sure the IT, and that's a great example of collaboration. If those guys are working together, how much more you can get done and how much more value you can get from your plant floor system. And go to the next slide, Mo. Yeah, so breaking down the silos of IT and OT, getting the data collection, connectivity, and reporting. That's the foundation, really. We talked about data collection being the foundation of Industry 4.0 and what you can do with that data and how you can drive results from that data. So that's what we're doing right now at Detroit Manufacturing Systems. We're getting a more modern MES system in place. It is a very complex system because we're a just-in-time, just-in-sequence place. That data is super important. But then we're connecting data across the manufacturing. We're not just collecting it because we have to collect it, or collecting it because we have to make sure that we build the right part at the right time in the right sequence. But we want to be able to use that data and connect it across the production floor. And you know, you think too about people. We have a lot of people involved with our assembly. And so we've discussed ways that we can use that data from the MES. If someone that works on a particular station on a particular line can you know, log into a station, we can collect data from that particular person. And maybe there's a particular problem that keeps happening at that particular station that's causing a quality issue, but we won't know that unless we start connecting, you know, the dots, connecting those things together. And then the second one is we have nothing in our injection molding right now. So we're going to put in a MES system in our data collection for injection molding. And so we have some visibility and alerting. And we're going to look at not only once we get that data and start visualizing that data, we're going to start looking not only at predictive maintenance from that data, but also what's happening with that machine if there's a quality glitch. Can we trace it back to some settings or some parameters on the machine, something that's happening on the machine? Maybe there's a spike in energy. Maybe there's something else going on, but we can't make that connection unless we start collecting that data and visualizing that data. You can go to the next slide, Mo. So here you see an example. This is an example of a MES system that we have in there. The performance analytics that it has. So we're going to have some new technology as far as tracking barcoding. It does some RFID actually with our employees. Of course, standard reporting is really important. It's going to track our cycle time and our OEE and our downtime, and then our product birth certificate history and things like that. So this is just an example of one of the MES stations that we have in our facility. And you can go to the next slide, Mo. Yeah, so then what do? You start collecting the data. We talked about it with the injection molding. Start generating machine health. We can see how healthy the machines are, and Mo talked about it in depth of what can we do with that, what's under the iceberg. So you can visualize it, we can collect it, but getting under the iceberg and figuring out what we can do with that data. Can we use some AI and machine learning and see what's going on with the data? And I'll give you a perfect example of what we did actually in a facility in Akron, Ohio. We walked into that facility, and it's an older facility that has very old machines. I mean, probably 1950s, early 60s type of steel stamping machines. And there was one line that had a particular issue when this one machine would go, roll forming machine would go down, that it of course would stop the line and cause big issues. And so when we walked in there and presented them, said, hey, this is Industry 4.0. It's really about connectivity and where the data is. And we really wanted to do an evaluation of where we're at. And we looked, they said, well, this one machine is an issue. What can we do? So we took a deep look at that one machine. And so we really narrowed it down just to the top tooling and lower tooling of the one particular machine to see what we could do with that machine as far as machine health and doing predictive maintenance on it. So you can go to the next slide, Mo. I'll continue here. So with that in mind, I learned pretty fast in this process that, you know, I always heard when I started this, look for the low-hanging fruit. And I honestly am not so sure that's true. I think you want to look for the biggest bang for your buck. I would say that is the thing that you want to look for. Industry 4.0 is a very, very complex idea with a lot of different scenarios and different technologies that are involved with that. And if you think about it as the whole concept, you can get really stuck. And sometimes you can get stuck in this perpetual science project where you're trying one thing out, trying another thing out. But what I learned really quick was just like us going into the Akron facility, is if you find one area that is a big bottleneck or a big problem, that is something that you can replicate in other machines or other facilities, that's what you really want to go after. And we talk about ROI. That is, you think about if this machine breaks, what's going to happen? Or if this machine starts misbehaving and we have some bad quality, how much could that cost us? So my thinking was to look for those specific ideas, but have the big picture in mind. So think big. If you look at the top there, think big, start small, prove value, and scale fast. So if you have the big picture in mind of Industry 4.0, but then let's look at very specific problems. Start small with a very specific problem. Go to the top tooling and low tooling of that Akron machine. We don't have to tackle the whole machine. We just tackled two parts of the machine. We were able to put sensors on there for a relatively inexpensive price. So it didn't have sensors previously, so we didn't have sensors. We didn't have connectivity. But for me as an IT guy, that's the easy part. The hard part is really finding the right project, finding the right group of people who will collaborate together, and then you can prove the value. We were able to fix that machine and I think predict that machine would fail in 10 days. And after we censored it up and after we started collecting data, the algorithms told us the machine's going to break in 10 days. Well, it gave us a 10-day window for us to do preventative things on that machine with those particular pieces of that machine to prevent that machine from going down. And that in itself is the ROI right there. And I think that's easy to take the leadership if you can show them the value of that. So once you think big, you start small, you prove the value, and then once you prove the value, you don't want to be stuck in limbo, in pilot purgatory, as they call it, but you want to scale fast. So have a plan to scale fast and replicate that across your facilities or across your plant. So that is my message to you and kind of a story of my journey. And I think that's my last slide, right? I'll pass it back to you.
Thank you, Isaac. Thank you very much. It's always informative to see a very practical journey through the digital transformation domain. I'm going to wrap it up, and I'm going to show a simple slide that just gives you the takeaways from the messages that Isaac and I try to convey here in this presentation. First and foremost, I echo what Isaac said. Think big, start small, but surely act now. The markets have become very competitive, and the use of technology in general, the use of IoT, getting connected, capturing data, being real time and remote monitoring are key to remain competitive and to be successful in the journey. So start your digital transformation today, assess where you are, and act now, and keep in mind your ROI and the cost benefits around it. Once you have a strategy, make it operational, okay? Make it operational in a small scale. A proof of value is a business case and a technology deployment. Business case plus technology gives you a proof of value that can add value to your operations. Again, whether you're running a factory or whether you have products that you sensorize, the use of connectivity analytics is there to give you value within your factory and to give your end user value who's using your product, right? So have that, near zero downtime and near zero defect vision while you architect your digital journey. And last but not least, readiness again boils down to people, process, technology. Find the best place to start your journey within your operation, keeping in mind benefits surely only accrue as the weakest link. So find the best start where the people, process, and technology are there to work together hand in hand to deliver value. And thank you very much to the PMA team for having us today on the call. And we will always be glad to speak to PMA members for more details and to support you on your journey. So thank you very much for your time today, and we're open for questions.